chromatographic classification is a part where somehow kinds of this general classification is there, where specific method, stationary phase, and mechanism is also highlighted for different types of chromatographic techniques. So liquid chromatographic techniques, as it is shown over here: liquid chromatography, liquid and bonded phase chromatography, liquid solid, size exclusion, and ion exchange chromatographic techniques are given. So what can be their stationary phase, and what can be their several level different types of the mechanism, that is also shown over here. Then gas chromatographic technique, where mobile phase will be gaseous in nature, and supercritical fluid chromatographic technique, where mobile phase will be supercritical fluids. Okay, so these are this is a new technique which we have not discussed previously, a kind of new technique where mobile phase is supercritical fluids, because we the people know several types of these chromatographic techniques are there, and some of these techniques have different mobile phase. The mobile phase can be gaseous also, it can be liquid also, and third type, which is supercritical fluids, which is in between gaseous and the solid forms. So this kind of chromatographic technique is also used. Then another kind of chromatography technique, that is called adsorption chromatographic technique, which is normal phase, where normal means mobile phase itself will be non-polar. So this is the example of adsorption kind of chromatographic technique, where stationary phase is silica gel, and that is having these kinds of silanol bonds. Okay, and here you can see the silanol groups. Why they are termed as silanols? Sila itself stands for silicon, and all basically that stands for hydroxy groups. So whatever the hydroxy groups which are present over here, they are generally making somehow kind of the hydrogen bonds, and these hydrogen bonds can interact with the water molecule. Just like last time I have discussed that silica gels are these kinds of material, they are, we should keep always them in anhydrous containers, because if we do not keep them this silica gels in anhydrous containers, then they will, I mean to say, generally, after adsorption the moisture, they will become inactive. And to prevent their inactivation, silica gel should be stored tightly in a container, and always should be stored majorly in desiccator or moisture-free environment. Because if we do not store silica gels in a moisture-free environment, and once it will absorb the moisture, then they will become inactive. So under these circumstances, it is very much necessary to make the silica gels active. There are also ways to activate the silica, where the people are heating it at a certain temperature, or drying it in an oven, or sometimes they are using the desiccators to absorb the moisture and to make them active. Right? Then here, if a terminal silanol group is there, then terminal silanol groups, which will have total 3 hydroxyl groups, and this can interact with other kinds of reaction or chemical constituents of whose separation which we want. Then it comes to adsorption kind of chromatographic technique, where another stationary phase after silica gel is the alumina. So Al2O3 is the molecular formula of this alumina, and that is also anhydrous in nature. You might have visited this name of Al2A3 in Friedel-Crafts alkylation reaction. So that alumina, Al2O3 aluminum oxide, that is also widely used as a kind of separation for as a stationary phase for separation of the molecules. And Al2O3, that is also having its structural framework, and that is majorly useful in adsorption kind of chromatography, and sometimes it shows tailing because of strong adsorption on silica. Some of the polyamides are also used as stationary phases. So polyamides are also having those kinds of properties where they can be used as the stationary phase. Separation mechanism. So before we come, this is our second session on chromatographic technique. So before we go in the depth of this technique, we must have pure knowledge what is called stationary separation mechanisms. So under which the first type of the mechanism is called adsorption, where a boundary reaction between a dissolved substance and a solid substance is there. So adsorption chromatography, which is majorly there. So it is a kind of surfacial phenomena, a kind of boundary interactions between the stationary phase, sometimes mobile phase, or the constituent which is dissolved in mobile phase. Dipole-dipole interactions, though this is a kind of interaction which is majorly applicable for two dipoles. Di means two and pole means the end. So one end if it is positive, other end will be negative. So this kind of this kind of the substance is termed as a dipole. Simple example is water, which is having H plus and OH minus, so that is also called as dipole because it is having two poles, H plus, OH minus. HCl, HF, HBr, all are the examples of dipoles because they are also having two poles, dipoles. H plus, Cl minus, H plus, Br minus, H plus, F minus are termed as these kinds of the dipoles. Okay. Then another concern is called as a hydrogen bond. So hydrogen bond is this basically kind of electrostatic interactions which is possible between the hydrogen and electronegative atom such as oxygen, chlorine, or halogen, or nitrogen, or even it can be some other electronegative atoms. So that is neither a covalent bond nor ionic bond but a kind of hydrogen bond. Okay, a single water molecule can make four hydrogen bonds. So this is another kind of interactions which a chemical constituent can have with our stationary phase hydrogen bond. So if our chemical constituent is having OH, NH, SH, fluorine, or sometimes a free hydrogen, so they can interact with the silanol groups of silica and or aluminum oxide to make the hydrogen bonds. So hydrogen bond is also a way of interaction between the chemical substituent and our stationary phase. Then it comes to the pi complex. So pi-pi interactions or sometimes pi-cation interaction, pi-pi stacking interaction is a third type of interactions which can be also possible. Okay. Then it comes to charge transfer complex, where pi complex are generally referred as charge transfer complex. So sometimes it may be kind of ionization or interaction between the system that may also be the part of this. Steric interactions. So because of the mechanisms or interactions described above, the molecules can also show this kind of the interactions. Just like we the people are having, human are also having interaction. Let me give you one of the example. For example, if I am a human being, okay, then for my name is Dr. Tejas Dhamelia, but I may be someone's father, I may be someone's brother, I may be someone's son, or maybe maternal uncle or whatsoever. So easily I am also having interaction with other human being through some other kinds of relations. I may be the best friend for somebody else, or for somebody else I may be the enemy for as well. Okay, so this way a human is having interactions with other human. I may be Indian, somebody may be Chinese, or other people may be Japanese, or other people may be American. So all these are what basically a kind of interactions. I'm Indian. I belongs to like sometime, for example, somebody may be by religious way they may different. They may be different by the caste. They may different by their religion or region, or even some may be villagers. Some may be from city. So what are these? These are basically a kind of interactions, a kind of relations, a kind of different perspectives. Okay, so if a human being is having this kinds of perspective, and then we have certain relations also. So here molecules are also interacting with another molecule through the several types of relationships. This relationship, these interactions can be hydrogen bond, it can be electrostatic interaction, it can be pi-pi interaction, pi-cation interaction, or it can be let us say this steric effects, that is also a kind of interactions between the molecules. Then it comes to adsorption chromatography. So here this is the example where steric interactions is shown there. If we are having simple phenol, then phenol का जो phenoxy oxygen that can make the hydrogen bond with the hydrogen of silanol of silica. So as shown over here, this phenoxy oxygen of phenol basically can make a hydrogen bond with the hydrogen of silanol groups. Okay, and this way it can show the interaction. But moment we add here a tertiary butyl group such as this, then this tertiary butyl groups will hinder the reaction. Okay, आपने रामायण देखा होगा, तो नहीं देखा है तो I'm not promoting you to see and watch it, but there is a role of mantra over there. So what she has done in the Ramayana? She has snapped the uh, Raj Mukut, a kind of kingdom from Lord Ram, and Lord Ram has to go for exile of 14 years. Okay, and then he came back, and then all the people repented, including Kaikai and Mantra. So what Mantra has done, she influenced the Kaikai. Later on, Kaikai influenced the Dashrath, and then Ram decided that if my father has ordered me to go for the exile of 14 years, then I will go for the same. Okay, so that mantra in coordination with Kaikai didn't allow the Ram to be king. Otherwise, Lord Ram may be the king of Ayodhya 14 years before. So Ram રાજ્યનો જે સમય હતો એ કદાચ 14 વર્ષ વધારે હોત. But say why is this? So that is the role of mantra which didn't, and Kaikai which didn't allow this. Okay, fine. In what जो भी होता है वो अच्छे के लिए होता है. But here also this is a role of tertiary butyl groups which are present over here, and they are hindering this oxygen to interact with the silanol groups and to make the interactions. Okay, so hindered phenol, if we have a reaction mixture which consists of phenol as well as hindered phenol, so hindered phenol will elute first because it is not having any kind of interactions, but a simple phenol will be retained by the silica, and that is not going to elute because it is having interactions likewise here. So as it is suggested over here, specific interactions of adsorption of solute in liquid phase with the surface of polar solid adsorbent. List polar molecules eluted first. So remember this कि जो मॉलिक्यूल नॉन पोलर होता है वो सबसे पहले बाहर निकल जाता है because non-polar molecules is not going to interact with the polar mobile phase or polar stationary phase. That's why non-polar molecule will come out first. Even if you are doing thin layer chromatography, तो सबसे ऊपर जो molecule होता है वो non-polar ही होता है. Polar molecule होते हैं वो सबसे लास्ट में रहते हैं इन TLC में, बॉटम लाइन नहीं रहते. आपने TLC परफॉर्म किया है during your B farm. Okay, so polar compounds will be at the last, at the bottom, and non-polar compounds will be eluted first or will come at the bottom. This is the question which is generally asked to medicinal chemists or natural products scientists in certain or students in certain kinds of viva whenever they will appear. कि बोलो दो कंपाउंड है, एक नॉन पोलर है दूसरा पोलर है, तो कौन सा स्पॉट ऊपर आएगा कौन सा स्पॉट नीचे आएगा, or else which compound will come out first from column chromatography and which compound will be retained in the column chromatography. So this principle is applicable over here where a non-polar compound will come out first and this polar compound will be retained. So non-polar compound will be at the top in thin layer chromatography and polar compound will be at the bottom. Then it comes to the elution pattern. So elution pattern of several of the compound is also of our concern because this elution way they are going to interact. Now this elution pattern is completely different for different substances. For example, alkanes, olefins, aromatics, and these are all non-polar compounds, so they will come out first. Then it will come for sulfides, ethers, nitro, sulfones, sulfoxides, and amides. So they will be in between. On the carboxylic acids will be the last. So normal phase mein, this is a elution pattern which is generally favored. That alkanes will come first because normal is a phase where mobile phase is non-polar and stationary phase is polar in nature. इसीलिए जैसे जो स्टेशनरी फेज का नेचर होता है उसके टाइप का कंपाउंड लास्ट में रिटेन या रिटेन होता है या इल्यूट नहीं होता है. सो इसीलिए जो पोलर कंपाउंड सच एज कार्बोक्सिलिक एसिड, अमाइड, सल्फोक्साइड, सल्फोन्स, alcohol, amines will be retained by such polar mobile phase. Then reverse phase is a phase as we have discussed where mobile phase is polar in nature and stationary phase is non-polar. So stationary phase itself is non-polar. So non-polar compound last में look होता है. All the aliphatics, all the kinds of alkanes, alkenes and aromatic compounds will be reversed. तो यहाँ पे जो normal phase में होता है उसको exactly reverse कर दो तो आपका reverse phase का elution pattern आपको मिल जाएगा. Elution pattern means to elute. To elute means to come out. If we are performing column chromatography, which consists of two components, polar component as well as non-polar component, so which compound will come out first? Which compound will elute first from column chromatography? That is called elution pattern. So I repeat, if we are handling with normal phase chromatographic technique, so alkane will come first because normal phase where stationary phase is polar in nature, so alkane is itself is non-polar, so non-polar का polar के साथ interaction नहीं होता है, इसलिए all the alkanes, olefins and this aromatic compounds will eluted first. Then it comes to carboxylic acid. So carboxylic acid is polar in nature. So that is going to interact with the stationary phase and that will be eluted later or it will be retained itself in column chromatography technique. Then this reverse phase, well reverse phase mein mobile phase is basically polar in mobile phase is polar in nature and stationary phase is non-polar. So if stationary phase is non-polar, then non-polar compounds will be eluted in the last. Light dissolves light. Non-polar can have interaction with non-polar and polar can have interaction with polar. Okay, so this is one of the phenomena which is over utilized, and in reverse phase, readily water soluble compounds are more eluted than hydrophobic ones. So they are also having those good separation for polar compounds where no deactivator is required. And this is last kind of one of the slide which we wish to discuss, a kind of partition chromatography or reverse phase chromatography technique where some of the kinds of substances are used. We can also convert silica into non-polar also. C18 column is this kinds of the columns where we can convert silica, a polar stationary phase, into non-polar stationary phase. So how that is possible? So this can be possible by attaching the silanol groups of hydroxy groups of silica gel with long alkyne chain octadecyl. C18 stands for octadecyl, which is 18 carbon containing longer chain. So if we connect this 18 carbon longer chain, which is called octadecyl, if it is 8, then it is called octadecyl. But if it is 5, 5, 10, and plus 3, so that is called from 8 plus 8, so that is called octadecyl, 18 carbon containing long alkyl chain. So here, once we have converted this into 18 carbon containing long alkyl chain, then it is also non-polar stationary phase. Now it is open to interact with naphthalene, which is a non-polar compound, but it is not going to interact with phenol because it is polar in nature. अब non-polar का interaction non-polar के साथ होगा, non-polar का interaction polar compound के साथ नहीं होगा. Okay. Mobile phase. So previously we have seen the elution pattern depending upon the stationary phase. Here this is elution pattern for the mobile phase, for normal phase chromatographic technique as well as for reverse phase chromatographic technique. So it was dependent upon the selectivity of the solvent, that if our heliotropic series is provided over here. What is heliotropic series? Heliotropic series means solvents in order of increasing polarity. So जिसकी polarity ज़्यादा होगी वो सबसे पहले होगा. As you can see, water is having highest polarity. Then methanol, ethanol B also should be here. Acetonitrile, dioxane, acetone, chloroform. We have petroleum, ether, pentane, hexanes are also there. Reverse phase chromatographic technique, where also elution heliotropic series is given, where water will be the last और जो pentane hexane है वो सबसे पहले बन जाएगा. Okay, so mobile phase is there. Then bonded phase chromatography technique, where we can use chemically modified silica, which is in the non-polar form or the polar form also. So this is a kind of phase where silica gels were there, but they have been coupled with nitrile groups, and we can modify. So depending upon our needs, several modified silica gels are also available, and they are widely used in these kinds of techniques. So up to this, we shall be stopping from here, and we have discussed several types of chromatography. What are the types of techniques, depending upon the mechanism, depending upon the size, depending upon the polarity, depending upon the nature of mobile phase, etc., etc. And we have seen little depth of these techniques, which we might have learned previously, but we took a chance to revise this. Okay, so for this session, let us stop up to this. In the next session, we shall be starting some other kinds of chromatographic techniques, such as high performance liquid chromatography or thin layer chromatography. So let us restrict up to this. Thank you, everyone. Thank you so much.